So far, we've only talked about sine and cosine in terms of what the graphs look like. Uh, but we do have six trig functions. Um, the next one we're going to talk about is tangent, and then we'll eventually talk about the other three. But if you know sine, cosine, and tangent really well, then you can figure the other threes out. A big thing about tangent is the period this time is 180, and it's kind of a different situation here. It usually isn't from 0 to 180, though it could be. I'll highlight here from 0 to 180, and I'll pull that shape out so you can kind of see it away from the graph there. That could be the shape, but we usually don't think of tangent as that kind of function with the asymptote right in the middle there. How we usually think about it is starting from the negative infinity, kind of curving up and going to the positive infinity. I'll pull that aside so you can kind of see it separately there. That's usually the kind of the image we think of when we think of tangent. Um, the center of it would be at 0, and you might notice here there's a limit on the domain. The domain has a limit. Basically, theta can't be 90, or whatever the input is can't be 90. So if you add 180 to that, it also doesn't work. So it's all the multiples there, and that's why you can see they've got these asymptotes every 90 degrees, or every other 90 degrees along your path. So every 180 degrees apart, you've got those two things, and that's the period, 180, right? Um, but you've got little vertical asymptotes. The middle always kind of goes through the center line, and you can see it's kind of curved there. There's a little center piece, kind of flattens out at that point and then comes right back up. But that's the shape that you're looking at. A couple important things here. Just like sine and cosine, there are ways to find the intercepts inside of one cycle. And for that, they do consider uh, the weird shape, like the shape split by the asymptote. Uh, but another important thing is there's no amplitude. It goes to positive and negative infinity. How can you have a minimum or maximum? That doesn't make any sense. The a value does actually change things in a graph, but we don't really use it that much yet. But it doesn't define an amplitude. All it does is it basically, that part in the middle, that's kind of where it's kind of slowing down and then changing back up and going steep again. It just changes how flat or how curved that is. That's all it does. Um, Here's an important thing: the asymptotes, uh, 180, or if you're talking about radians, it's going to be pi over 2 times the absolute value of b, 2 times the absolute value of b. And it's very important here that b is odd. We just want every other one. So we're not going to do the evens, we're just going to do the odds. For example, if b is 1, 180 times over 2 times 1 is 90, and you can see that is where one of the asymptotes is, right there. If we were to plug 2 in, we'd get 4 going into 180. What is 4 going into 180? I should know this one. We'd get 45. But you can see at 45 degrees, there's a value. There's no asymptote there. So we end up having to just um, change that to a 3, and it's 180. Oh, sorry, no, it's not. It's not that. It's not odd multiples where b is odd. Sorry. We figured out like the first one here would be 90, and then we don't double it. We multiply it by 3, and we get 270. And that's where the next one is. 90 times 5. That's 450. So you're finding this value and then multiplying it by 3, 5, 7, and that will give you your other asymptotes. We'll cover that in a second as well, because we'll have to do that one. All right. Let's actually graph one of these things. Okay. Graphing of the tangent function y equals 2 theta. So with y equals the tangent of 2 theta. Our b value is 2. That gives us a couple things to work with. We're going to go through 0, 0, and then we're also going to have a period of 180 divided by absolute value b. Oh, I think I forgot to mention that. If you look closely on this chart here, normally period is 360 divided by the b value, but because the base function only has a period of 180, you're actually going to do 180 divided by the absolute value of b. So instead of 360, we got 180 divided by absolute value of 2, which is going to be 90. So now we have a period of 90. So we're going to find some asymptotes here. So we got 1/2 times 360 over 2. It's 360 divided by 4. That's going to be 90, comma 0. All right. And then we're going to have 360 divided by 2, comma 0, which is just 180, comma 0. So there's my 3 intercepts that I'm going to work with here. I also need to figure out the asymptotes. And the way I do that is I take 180 divided by 2 times the absolute value of the b value, which is 180 divided by 4, which is 45. And now I'm going to take 45 and multiply it by 3. And I've got myself 135, right? Yeah. And then I'm going to go back in the other direction there and multiply it by -3, and I'm going to get negative 135, right? And by -1 would be negative 45. Okay, so now I've got my asymptotes here. Let's go ahead and draw this out. Okay, so my asymptotes are at 45 degrees. So I'm going to have multiples of 45 kind of be one of my marks here. So let's go ahead and do 45, 90, 135, 180, and then 215. Oops, 215. Isn't that right? I'm trying to remember my unit circle. Let me double check that one. 45 times 5, 225. 225. I knew something was off there. 225. And I'm going to do the same thing in the other direction. Negative 45. Skip a spot. Negative 135. Skip a spot. Negative 225. Okay. Draw in my asymptotes. So at 45 and negative 45, 135. And one thing you can kind of do when you're drawing this to check, between the first two, I have 4 spaces. 1, 2, 3, 4. Between the next two, I have 4 spaces. So I'm pretty good there. That's working out. Oops, didn't want to delete that part. Just wanted that part. And you know what? I think I'm done with my asymptotes there. I drew too much graph. Now in blue, I'll draw in the tangent line. And you can see here in the very beginning, I go through 0, 0. And at 90, I go through 0. And at 180, I go through 0, which probably means I've got it on this other side as well. Start from the bottom. As I get close, I flatten out. Then go back up. Start from the bottom. As I get close to the axis, I flatten out. Then curve back up. There we go. Bottom, flatten out, curve back up. Bottom, flatten out, curve back up. And there's how you graph a tangent function.